Now let's look at the world we actually live in. First of all, we can look at it at three main levels: the large, the small, and the complex. Now, it all, and Matt mentioned this yesterday, it all really starts with this little guy by the name of Al Einstein, who had a really boring job in this Swiss patent office. So if you have a boring job, stick with it, okay? Just make sure you have a good imagination. He really was not happy with Einstein's notions of absolute space and absolute time. As he was imagining, what is light and what is time, he began to realize that, time is the measure of what flows, but, you can measure time here on the platform or on a moving train. The laws are the same, for each person, but in a sense, they are not absolute. So what Einstein basically realized after taking a week off and spending it in his bedroom, there's a great story about how he went to his bedroom, and he told his wife, Elsie, he said, I'll see you in a week. I need to really think about this thing. And so she said, okay, dear, just let me know when you're done. I'll give you your dinner. So he came down one morning, like in his bathrobe and slippers, which he did a lot of, with like a single piece of paper that had just like all mathematical symbols on it. He said, honey, he said, this is going to change the entire universe. And she said, that's great, dear. What do you want for breakfast? And that's basically what he did, right? He really just ushered in a whole new understanding of not space and time, but space-time, right? His theories of general relativity and special relativity give us a whole new understanding of matter and energy and gravity itself. So space-time is, in a sense, a very elastic, whatever it is, it's this universe that's not built of Legos, as Newton thought. These are not building blocks that God put together, like a giant Legos player. The universe is more like bazooka bubble gum, where you have a wad and then you start pulling it outwards. Or it could be like a slinky, in a sense. I like the bazooka bubble gum better because I like to blow bubbles. But as it's expanding, space-time is forming. Now that's really kind of what? And as it's forming, and there's the beginning of clumps in this space-time, gravity is, in a sense, the heaviness that's actually bending this space-time continuum. So here's our universe, right? Here's our real story. We are about 13.8 billion years old. Now that is really, really, really old. So if you're feeling old this morning, think of 13.8 billion years old. You can't get your head around it. It has a beginning that's as mysterious as anything to scientists itself, right? We come to a point that's called the singularity, which means our mathematics just don't go any further. We just simply can't say what exactly the beginning is. And so there's all sorts of speculations, right? There's all sorts of theories. Did we emerge out of a previous universe, out of a black hole? Are we one of many universes? I like that one. What if we are a universe that's operating in tandem with at least one other universe or several universes, given the fact that there's trillions of galaxies? It's pretty amazing that we would be the only ones, but I know we're special. Anyway, this universe begins as just a hot, really just like a speck. And it's hot, dense, it sort of rapidly expands, and then it starts to cool, slow down and cool. And as it's cooling, we begin to see the formation of the stars, the formation of the planets. And we know today that most of the energy is dark, most of the universe is dark energy, and we do know that it is expanding faster and faster. That's actually a more recent discovery. Now, there is a small portion of energy that's called dark matter, and that's, in a sense, the energy that keeps things together so that we don't fly off, and just dissipate entirely. It is just an incredible universe, just amazing. And it's, we're in this universe, we're just one of billions of galaxies. Really, we're in a suburban galaxy called the Milky Way, there's probably local, yeah, I bet there's Starbucks and McDonald's, by the way, in other parts of the galaxies. Anyway, we're in groups of clusters, we're in little neighborhoods, about 2,000 or so galaxies together. To think that we'd be the only form of intelligent-based life, seriously? I mean, really. God is not that boring, really, I want to tell you that right now. So it is expanding, and we know ourselves to be expanding with it. It's our cosmic litmus test. Now, here's, I think, where our understanding of things begins to be really challenged. And it's in the question of nature itself. What is matter? What is matter? I think a lot of people still think of matter in the Aristotelian sense, substance, substance and form. When in fact, one of Einstein's insights in his special relativity is that matter is a form of energy, right? Matter and energy are interconvertible. I mean, all you'd have to do is take, for example, a drop of water, right? And you would heat that water up, and it moves to a different energy state. And we call it steam or vapor. And then you might freeze that drop of water, and it moves to another energy state that we call ice. It might be the difference between, say, Boston and Winter Park, Florida, too, ice and steam. Anyway, energy is the stuff of what we're made of. Energy. So E equals mc squared, meaning our bodies are energy, so to speak, packed into forms. And it got weirder in the early 20th century when we began to realize that energy is not so easy, in a sense, to pinpoint down, what exactly is a particle of energy, what exactly is a wave, what is a photon. We began to, in a sense, explore these realities. That Einstein had a real problem with quantum physics because his famous saying, God does not play dice, right? God is, God must have known what God was doing in all of this stuff. And Niels Bohr said, Al, buddy, get a grip. Because, every time you try to measure something, this is Heisenberg, every time you try to measure something, you're going to alter its either position or velocity. And so they did experiments, where they shot these electron beams through slits. I don't know what you're doing tomorrow morning, but you can try it. And they realized, I get this strange pattern. It looks like a wave, but it looks like a particle, and I can't tell if it's a wave or a particle unless I observe it. And that's what quantum physics really has introduced for us, the fact that the subject is important to what is, in a sense, being named, right? So it's not just a purely objective universe. The mind, consciousness, now plays a fundamental role in the determination of matter itself. So as James Jean noted in 1950, mind no longer appears as an accident into the realm of matter, but mind may be the creator and governor of matter. Mind may be the creator and governor of matter. We're not there. We're pretty sure that it's matter. Oh, and by the way, we have these things called minds. And quantum physics and early physics tells us we may have just be on the wrong side of the tracks. Jean says, the quantum phenomenon makes it possible to propose that the background of the universe is mind-like. Or as Freeman Dyson said, did the universe know we were coming? So matter is not composed of just building blocks, but complicated webs of relations. Cosmic life is intrinsically relational. Fields within fields within fields of energy. One of the phenomenon of quantum physics was this thing called quantum entanglement. And this was a phenomenon that was proposed first as a thought. Einstein, again, very leery of this stuff, had two postdocs. Great to have graduate students, by the way. And they said, well, what if we, imagine that two particles interacted, and then we separate those particles? And we put, say, one particle here on the desk in Winter Park and the other particle on the moon. What would happen if we turned this particle 180 degrees up, and they speculated, I bet the particle on the moon, if indeed these are interacting particles, the particle on the moon should turn 180 degrees down. And Einstein was like, really? It was later shown to be true. This is called spooky action at a distance. It's spooky, right? Or non-local action at a distance. And I think, one of the greatest examples of this is consciousness itself. We're constantly interacting, right, with one another. And I always say, well, think of someone that you've worked with, that you have interacted with, and that person moves away. They move to Florida or to Alaska, and one day you have a thought. A thought arises in your mind, and in the next half hour, you get a phone call or an email from that person you were thinking about. And you would say, oh my God, I was just thinking about you. We used to say in the Ptolemaic cosmos, what a coincidence. Now we say in the Einsteinian cosmos, we're quantumly entangled. So I want to just tell you this, be careful who you interact with. It is forever. I think that maybe that is the new definition of heaven, maybe, or hell. It depends. So what is nature? What is nature? This is a huge question. I'm going to come back to this again when I talk about artificial intelligence. It's less and less, I think nature is a very elusive term, by the way. I don't think we really know what we're talking about sometimes because quantum biology, and I see Ed Olson is here, quantum biology really pulls biology into a new level of understanding today, where we understand that reality is non-local. So nature is composed of material substances or energy fields that are deeply entangled. What we do know is the stuff that we call nature is really, on a fundamental level, undivided wholeness. Paul Dirac in 1933, where he had, they had those dinners, the night before the prize, before his Nobel Prize, he got up and gave this little talk, and he said, this whole field of quantum physics and quantum entanglement is such incredible. He said, it's like if you pick a flower on Earth, you will move the farthest star. That's how entangled we are. Now, just think of our actions, our everyday actions, having cosmic effects, having non-local effects. And Henry Stapp, the physicist Henry Stapp, said this goes even to our thoughts. If I think negatively, if I think I hate that person, if I think what a jerk, we wouldn't even think that that thought can have effects, non-local effects. Which means, do we have a part to play in the war in Iraq, in the drought in the Sudan, certainly in the conflicts in our own country? We are not in a Newtonian universe anymore, and we need to wake up to our deeply entangled lives. David Bohm, wonderful physicist, a contemporary of Einstein, who had a whole understanding of implicate order. He said there's this, that there's even in the midst of this quantum movement, there is a quantum potential. There's something that holds the whole together, so to speak. And he couldn't name exactly what that was, but he said it's so entangled that it is, as humans and beings and societies, we seem separate. But in our roots, we are part of an indivisible whole, and we share in the same cosmic process. We, North Americans, South Americans, Russians, Chinese, Afro-Americans, Hispanic, immigrants, you name it, we are all deeply entangled together.